Okay, so first question, it says solve 2 times the quantity of C minus 5 minus 2 is equal to 8. Okay, so first thing we got to do is we got to write the equation down. Then we have to remove the parentheses by using the distributive property. So we're going to take 2 times C, which yields 2C. 2 times a negative 5 gives you a negative 10. Minus 2 is equal to 8. Okay, you can combine these at this point, this negative 10 and this negative 2, to get 2C minus 12 is equal to 8. Then remember, when it's solving, we're in the process of trying to isolate the variable. So we want to move everything from this side to this side except for C. So we're going to plus 12 first on both sides and get 2C is equal to 20. Then we're going to divide by 2 on both sides to show that C is equal to 10. Okay, pretty simple, pretty easy. Just a simple 2-step equation. Get your minds rolling. Next one. Inequality, and graph it on the number line. So we're going to solve 2b minus 5, which is less than or equal to negative 1. Then we are going to graph it. So 2b minus 5 is less than or equal to negative 1. So here's our inequality. The same way that we solved that last equation, we're going to work to isolate the variable. First step, since it's 2b minus 5, we want to bring this 5 to this side. So we're going to plus 5 on both sides. It's going to give you 2b less than or equal to 4. Then we would divide by 2 on both sides. These cancel out. B is less than or equal to 2. So on our number line, 2 is there. That's 3. That's 1. Okay, I'm going to have a closed circle on 2 with everything to the left shaded. Should look like that. And that corresponds to answer A of our multiple choice questions. Okay, number 3 says, which algebraic equation shows the sentence 4 plus a number divided by 6 is equal to the product of 12 and the same number? Okay, so here we have a plus, so we need to have addition in there. Okay, the key thing is it says 4 plus a number divided by 6. So we're going to be looking for a variable divided by 6 on itself. And then we're going to add 4, and that should be equal to 12n. Okay, so this one, looking at it here, A, 4 plus 6 divided by a number. So A can't be it. B looks like it has a strong choice because it's 4 plus a number divided by 6 is equal to 12n. Okay, so B is a front runner so far. 4 plus n divided by 6. We don't want that. Okay, that one, the distinction between these two is probably the hardest. Okay, but the way that the question is written, it states that the variable is divided by 6 by itself. So our answer should be B. Number 4, find the slope of a line that passes through 5, 7 and negative 1, 0. Requires you to use a slope formula, which is equal to M is equal to y2 minus y1 divided by x2 minus x1. Okay, and remember, it doesn't necessarily matter which one you choose for x2 and y2, as long as they are paired up as you're going down. So M, let's going to be equal to 7 minus 0 over 5 minus a negative 1. Okay, 7 minus 0 is simple. That's 7. 5 minus a negative 1 in all reality is 5 plus 1. So we should have 7/6. Right there, simple slope equation. Then here, write an equation in slope-intercept form for the line that has the x-intercept -3 and the y-intercept of 6. So if we remember anything about y equals mx plus b, the value for b is the y-intercept. Okay, so the question gives you that. All we have to do is find the slope. Okay, so our y-intercept, it's going to be a +6. So at this point, we can eliminate answer choice B in order to find the slope. If we have an x-intercept at -3, that's 3, 0. We have a y-intercept at 6. That's at the point 0, 6. So we would take and run it through our slope formula with 6 minus 0 over 0 minus -3. 6 minus 0 again gives you 6. 0 minus a -3 is really 0 plus 3. So that's 6/3. Simplifies down to 2 over 1 or 2. We would plug that in for our slope. And since they gave us the y-intercept of 6, we know our equation has to be y equals 2x plus 6. Which would correspond to answer D. Five-minute check. I think we got through in about 3 minutes. That's perfect. This lecture shouldn't be too terribly long. Hopefully not. Can't lie, my pre-calc lecture was pretty long, so my tongue's a little tired. So hopefully I don't mess up too bad. All righty. Okay, so we have identified domains and ranges for given situations. We've also talked a little bit about functions as well and using the vertical line test. We're going to do both of those things today as well. We're going to determine whether functions are one-to-one and or onto. Okay, and we're going to determine whether functions are discrete or continuous. Okay, so it should be a pretty simple section, pretty easy section, as long as the hard part is wrapping your head around it, the concept, especially when it comes to functions being discrete and or continuous. Okay, so here is our vocabulary. We have one-to-one function. Okay, I'm going to show you a test that you can use. It's called the horizontal line test. It determines whether each x value corresponds to a unique y value. An onto function is each item of the range corresponds to an item of the domain. A discrete relation is something that's broken apart, like a series of points. A continuous function is almost like a parabola, a line. Okay, it's what you're most used to when you're talking about graphing. The vertical line test. Once again, that's how we determine if a relation is a function. Okay, we have independent variable. Those correspond to your x values. We have dependent variable. Those correspond to your y values. We have function notation. And then codomain. So codomain as a concept is all of the possible y values. Okay, all of the possible y values, and each relation breaks down into a range, which is a subset of the codomain. So if you think about it, the codomain is the overhead, and the range is the individual subset that corresponds to our relation. Okay, it has a big determination on whether it's an onto function or not. Most functions and most relations, when you come to them, they are always onto, but at one-to-one is where it gets a little tricky. Okay, so here is our key concepts. We have one-to-one function. So each element of the domain compares to exactly one unique element of the range. Okay, so if you're looking here, we have 1 that corresponds to D, 2 that corresponds to B, 3 that corresponds to A. This would be said to be a one-to-one function, and this would pass the horizontal line test. Okay, and what the horizontal line test means is if we were to examine a graph like y equals x squared, okay, you'd have a dot on the origin. Positive 1 would map to positive 1, negative 1 would map to negative 1, 2, 1, 2, 3, 4, 2, 1, 2, 3, 4, and our graph would be a parabola that looks something like this. Okay, this is a function. Okay, this is a function because anywhere we were to draw a vertical line, and you can see it on the grid lines, we would only intersect the graph at one spot. So, is it a function? The answer to that is yes, it is a function. But what type of function is it? Okay, is it one-to-one or is it onto? If it is a one-to-one function, each element of the domain, so for here, I have the domain between -2 and +2. Okay, I'm working on this domain right here, -2 to +2. Each one of these x values would correspond to a unique y value. Unique meaning that it's separate from everything else. It's not going to be copied. Okay, but if you look at this graph, -2 maps to a +4 because -2 squared is +4. 2 squared is also a +4. Those are not unique. Okay, they're copied. -2 has the same y value as 2, right? Because when we square them, we both get +4. So this is not a one-to-one function. Okay, the test that you can use is called the horizontal line test. And what it states is that if a function is one-to-one, all of these horizontal grid lines would only intersect a single point and not a second point. Okay? So if I draw a line here, you can see I intersect my graph twice. That tells me that this is not one-to-one. Okay, it's not one-to-one. The horizontal line test determines if it is a one-to-one function. If it is one-to-one, it'll pass it. So if we were to draw up a graph, a simple one, just y equals x, so a line. It would look something like that. And you can see with these horizontal grid lines, if I were to draw them across, I only intersect my graph one time and one time only. Okay, so this would pass the horizontal line test. So this is what's known as a one-to-one function. Okay, it's if it passes it, it's yes. Yes, it's a one-to-one function. If it doesn't, it is not a one-to-one function. Okay, very similar to the vertical line test, where we determine if the relation is a function. Okay, so one-to-one needs to pass the horizontal line test. When you're talking about an onto function, okay, onto functions are much more common than a one-to-one function. And what it states is that each element of the range corresponds to an element of the domain. It does not have to be unique. So for your homework, most every function is an onto. Okay, that's because if it's a part of our range, chances are it maps to our domain. So you can see 1 maps with D, 2 maps with B, 3 maps to C, and 4 maps to C. This would still pass the vertical line test because none of our domain is duplicated. Okay, so that's the key. It needs to pass the vertical line test to become a function, but to be an onto function, the range will map to the domain. A one-to-one function, it passes the horizontal line test, and the domain maps to a unique element of the range, meaning that it's not duplicated or copied in any way. And then they can be both. So most lines, linear equations, y equals mx plus b, fall into both one-to-one and onto. That's because each element of the domain is paired to exactly one element of the range, and each element of the range corresponds to a unique element of the domain. Okay, so linear functions are always both. Okay, parabolas are never one-to-one, they're only onto. So that's your key concept there. Let's look at how to apply it. Okay, so state the domain and range of this relation, then determine whether the relation is a function. If it is a function, determine if it is one-to-one, onto, or both, or neither. Okay, so if you remember for domain you're talking about all of the x values. All of the x values, and when it's given to you in graph form, you always want to work left to right. Okay, from least to greatest. So starting in the bottom left, we have a point at -4. Okay, so -4 is part of our domain. We move even farther to the right. Starting from the left, we have a point at -3. Okay, we move closer, farther right, we have a point at 0. So 0 is a part of our domain. We move farther to the right, 1, and then we have a 3. So when it's given to you in graph form, you want to work left to right, okay, especially in the domain because it has to be written least to greatest. Now let's talk about the range. Okay, your range is talking about the y values or the applicable y values. So we want to start, because we want to write them least to greatest, we want to start from the bottom and work our way up. Okay, starting at the bottom, the first y value that we come to is -2. It is duplicated, so we do not have to write it more than one time. Okay, we only have to write it as -2. Move farther up, the next one we come to is 1. The next one that we come to as we move farther up is 2. And then the final one that we come to is 3. So here we have our domain. It's -4, -3, 0, 1, 3. And our range is -2, 1, 2, 3. Okay, once again, domain is x values, range is y values. Domain work left to right, range work from bottom to top. Okay, but now let's ask ourselves, is the relation a function? So we're going to use these grid lines, and we want to see if we intersect a point using the vertical line test, or if we intersect 2 points when we draw a vertical line. So we can use the grid lines to do this very easily. This one looks good. This one looks good as well. This one looks good also. We're good here. We're good here. Okay, all of the points, they only lie on one vertical line. We can say that, yes, this is a function. Okay, But now we have to find out, since we stated it is a function, we have to know if this is a one-to-one function, an onto function, both, or neither. So to determine if it's one-to-one, we want to use the horizontal line test. Okay? So if we look here, we have the point -4, -2, and then we have a point 0, -2. They lie on the same horizontal line. So this is not a one-to-one function. Okay, it failed the horizontal line test. It's not one-to-one. Okay, but is it onto? Do each one of the y values map to an x value? 3 as a y value maps to 3. That checks out. 2 maps to a 1. That checks out. A -2 maps to 0. -2 maps to -4. Remember, for onto, it does not have to be unique. Okay, it just has to map to an x value. Okay, since we have ordered pairs here, yes, this is an onto function. Okay, but it is not one-to-one. So our answer, as we would put it, we would list the domain from least to greatest here, which once again it was -4, -3, 0, 1, and 3. That's working left to right on the x values. The range from least to greatest, -2, 1, 2, 3. That's working from bottom to top. Okay, yes, it's a function. It passed the vertical line test. It's not one-to-one because each x value does not map to a unique y value. It's an onto function because each y value maps to an x value. Okay? So the domain, once again, listed from least to greatest. The range listed from bottom to top, least to greatest. Okay, it is a function. It passed the vertical line test. It is not one-to-one. It did not pass the horizontal line test, but it is an onto function. So full answer, domain here, range there. Each member of the domain is paired with one member of the range. So this relation is a function. It is onto, but not one-to-one. Most functions you'll encounter are onto. Okay, it's very rare that you get one that's neither. Because what that means is that you have a y value just kind of standing out there by itself. Okay, it's very rare that you would ever have that case. Here's the vertical line test again. Once again, this is what you use to determine if it is a function or not. Okay, that's the first question that you ask yourself. If it is not a function, it cannot be one-to-one or an onto. Okay, if no vertical line intersects a graph in more than one point, the graph represents a function like the one on the left here. A vertical line intersects a graph in 2 or more points, the graph does not represent a function. That's the one on the right. Okay, and what we have to remember is that these are infinitesimal. Okay, we have to go all the way down to decimal points. All the way down to decimal points for it to be a true function. All right. So second one, we're going to graph y equals 3x minus 1 and determine the domain in the range, then determine whether the equation is a function, one-to-one, onto, both, or neither. State whether it is discrete or continuous. So first looking at it, we have the graph here. Okay, we have our y-intercept at -1. We rise overrun 3. We rise 3 for every one we move to the right, so we get 1, 2. As we move to the left, we drop 3 as we move 1 to the left. Okay, here when you're talking about domain and range, we have to remember that these arrows extend off into infinity. Okay, they continue going. We can't assume that they stop. So the domain here is going to be all real numbers. Using interval notation from negative infinity to a positive infinity. Our range has to do the same thing. Okay, the arrows mean that the graph continues on. So our range and domain is all real numbers for both of them. But now we're looking to determine whether it is a function or not. So using the grid lines, is there any time that one of the grid lines intersects the graph more than once? Okay, going through from the picture shown, we can conclude that no, it doesn't. Okay, this grid line only intersects here. This grid line only intersects here, intersects here, intersects here. So yes, this is a function. Okay, but now is it one-to-one? Okay, does it pass the horizontal line test? So check. We can see that each of the grids, the horizontal grids, only intersect at one point and one point only. So this is a one-to-one function. It passes the horizontal line test. Okay, now is it onto? So once again, onto is asking if each element of the range maps to an element of the domain. So looking at this graph, we don't have just a stray y value, right? Our domain was all real numbers and our range was all real numbers. So that means yes, right? Because we don't just have a stray y value that doesn't map to an x value. So this is both one-to-one and onto. Okay, all of your linear functions are going to be both onto and one-to-one. Okay, I can see a couple cameras on. Just know I'm recording, so if you could turn those off. Thank you. Okay, but now we have to ask, is it discrete or continuous? Discrete means that it's broken up into pieces. Continuous means that you can draw it with one swipe of the pen. Okay? We would never have to pick up our pen to draw this. So in considering it goes on for eternity, right, we have to assume that the graph continues on this same plane. And since we can draw it with one swipe of the pen, it is continuous. It is not discrete. So our domain, all real numbers, the graph goes from negative infinity to positive infinity along the x-axis. The range, all real numbers, the graph goes from negative infinity to positive infinity along the y-axis. It's continuous. There's no interruptions in the graph. Or in other words, when we draw this, we would never have to pick our pencil up. It is one-to-one and onto. It passed the horizontal line test, and each element of the range maps to an element of the domain. So here's our full answer. Okay, domain, all real numbers, range is all real numbers. The equation is a function because it passed the vertical line test. It passed the horizontal line test, so it was one-to-one. Elements of the range maps to elements of the domain, and the equation is continuous. Okay, all of your linear functions are going to be this way. A linear function is never not continuous. Okay, a linear function is always both onto and one-to-one. Okay, a parabola is never one-to-one because it will never pass the horizontal line test. Okay, this is function notation. Okay, function notation is just a different way to express equations. So you have f of x, which is equal to x cubed minus 3. Okay, So here you can see the independent variable is whatever is in this interior parenthesis right here. Right there. The dependent variable is the solution after we plug this in. So when we just plugged in x, we got x cubed minus -3. Whenever you come across something like this, what is it? It is asking you to take this independent variable, whatever's inside the parentheses, and substitute it for each variable in the dependent variable. So since we have f of -2, we're going to substitute -2 each and every time we see an x. Okay, so it looks like this. Okay, then we would carry out order of operations to figure out what we are left with here. So -2 cubed, -2 times -2 is a +4, times -2 again is a -8. Okay, nothing gets subtracted from the constant, so it's still -3. So a -8 minus a -3 gives you -11. So f of -2 is equal to -11. Okay, it's called function notation. The key thing is, whatever is represented inside of the parentheses, we have to plug it in for each occurrence of the independent variable in our dependent variable. So just for instance, just to kind of prove a point, if it wasn't just x cubed minus 3, let's say it was x cubed plus x squared minus x minus 3. And that's f of x, and they're still asking us to find f of -2. Once again, we have to take this -2 and we have to plug it in for each time that we see an x. So we'd have -2 cubed plus -2 squared minus a -2 minus 3. Then we carry out order of operations, taking care of our exponents first. -2 cubed, like we just saw, was -8. -2 squared is 4, because negative times a negative makes positive, plus or minus a -2. So that's really just +2. And then negative minus 3. Then we would solve it going left to right, because we're down to just addition and subtraction. -8 plus 4 is 4, plus 2 is 6, minus 3 is 3. So we'd say that f of -2 is equal to 3. The key thing with function notation, whatever is shown inside of the parentheses, gets plugged in for each and every variable. Okay? And it doesn't just have to be limited to numbers. They can also put in other variables. Okay, like you'll see on this next one. But of the original one, we said that it was -11 as our answer. Here's the book walking through it. So our original function, f of -2, we plug -2 for each occurrence where there is x. -2 cubed is -8. -8 minus 3 is -11. So f of -2 is equal to a -11. The hard thing to remember, or the key thing to remember, is whatever's on the inside of the parentheses gets plugged in for each and every variable. Okay, here, given that f of x is equal to x cubed minus 3, find each variable, or each value. So we have f of 2t. So f of x is equal to x cubed minus 3. They want us to find f of 2t. Okay, once again, whatever appears on the inside of the parentheses needs to be plugged in. So f of 2t is equal to 2t cubed minus 3. Okay, this cube applies to both terms on the inside of the parentheses. So 2 cubed is 8. T cubed is just t cubed minus 3. Here, are there any other like terms that I can combine? Are there any other areas where I see t cubed? The answer to that's no. So this is the simplest form that I can put it in. So f of 2t is equal to 8t cubed minus 3. Again, they write the original function. They substitute 2t for each occurrence where there's an x. They evaluate it. 2 cubed is 8. T cubed is t cubed. Minus 3, there's no other constant. There's no area that we can combine like terms, so this is the simplest form. So our answer is 8t cubed minus 3. Okay. Table shows the average fuel efficiency in miles per gallon for SUVs for several years. Graph this information and determine whether it represents a function. Is the relation discrete or continuous? Okay, so first thing is we're going to have years on my x-axis. So here's years. We're going to have fuel efficiency, miles per gallon, on my y-axis. Okay, and now it's time to just plot them. Okay, so in 2001, here's my origin. My permanent marker is starting to be erased, which is no bueno. So here's 2001, 2002, 03, 04, 5, 06, 07. Okay, I'm going to count by fives here on my miles per gallon to save space. So 5, 10, 15, 20, 25. So in 2001, the average fuel efficiency was 20.8. So that's just above 20. In 2002, it was 20.6. So once again, we're just above 20. 03, 20.8 again. Just above 20. 04, 20.9. I should have just started my graph at 20. Just a little bit higher. 05, 21.6. So a little bit higher there. 06, 22.3. A little bit higher there. And 22.6 right there. So the question is asking us, does the relation represent a discrete or continuous function? So here, it does pass the vertical line test, so it is a function. But we have to ask ourselves, could I draw all of these individual dots without picking up my pencil? Okay, would I be able to make it in one fell swoop? The answer to that is no, I couldn't do that. Okay, so this does not represent a continuous function. I have to pick up my pen to make each dot. Okay, it is not going to be continuous. Okay, here's their graph. They do a much better job of graphing than I did. But you can see we can't, there's no possible way to draw all of these dots without picking up our pencil. So the relation is a function because it passes the vertical line test, but it is not a continuous function. It is discrete. Okay, or in other words, we have to pick up our pencil. Last and final one. Okay, commuter train ticket costs $7.25. Cost of taking the train x times can be described by the function y equals 7.25x. Okay, so where y is the total cost and x is the amount of tickets that we have purchased, or how many times we rode the train. If we correctly model this, would it be discrete or continuous? And looking at it, it fits the form y equals mx plus b, right? Just with 0 being b. But here's where we have to get conceptual. We have to think a little bit deeper. Okay? In any situation on a train, am I going to be able to ride it half? No. Each time I get on the train is one full ride. Right? I can't ride the train 1.5 times. Can't ride the train 2.5 times or 2 3/4 times. Each time I get on and off is one separate ride. So since I am limited by straight whole numbers, okay, my domain is only whole numbers because I can't have a decimal or a fraction of a ride. This can't be continuous. Okay, it's simply limited by the real world application, the concept. So why this does look like it should be continuous, because it fits the form y equals mx plus b, it can't be. Because if it was truly a continuous function, I'd be able to plug in 1.5 and be able to come and get an answer. In this situation, I can't ride the train 1.5 times. I can only ride it 2 times or 3 times or 4 times or 1 time. Okay? So when deciding whether a real-world situation is modeled by a discrete or continuous function, consider whether an interval of all real numbers makes sense as part of the domain. So that's layman's terms of that. Does it make sense to ride the train 1.5 times? Answer to that is no. Okay, so if a person buys 2 train tickets, it will cost $14.50. 3 train tickets, it will cost $21.75. 4 train tickets, $29, and so on. You cannot purchase 1.5 tickets or 2.25 tickets, okay, to ride the train. So that's saying that we can't have pieces of rides. We can only have whole rides. So since the domain consists of only whole numbers, this is correctly modeled by a discrete function, and the graph will consist of the set of unconnected points, 1, 7, 2, 5, 2, 14, 50, 3, 21, 75, 4, 29, and so on. So in this case, it cannot be continuous. It has to be discrete. Okay, and because the graph consists of distinct points, the function is discrete. There's no way to draw that without picking up my pencil. Okay, so that's kind of the hardest part about determining if it's discrete or continuous. Other than that, it's pretty simple. Okay, use a vertical line test. No vertical line can be drawn that contains more than one of the data points, so therefore the function is a relation. So in this case, it passes the vertical line test. So therefore we can conclude, yes, this is a function, but it is discrete. That's all I have for you. I am assigning your homework now. Your homework comes from page 91. It is numbers 2 through 38 evens. I'll remember that in the book, so if I bring up my McGraw-Hill, I'll drag it over there. I know you guys are just looking at a blank screen right now. Just give me a second. Have a little faith. You guys should be able to see the book now, right? Rock? Okay. So if I go to page 91, remember your little icons down here. Okay? This is a video tutor. You click on that if you ever get stuck and you don't like hearing my voice. You can always click here and find certain tutors. It also breaks it down into Spanish. Okay? Just use the resources that are available to you. Right? This purple button here is the tutor. That's probably the most useful one. The rest of these are more for me.